Okay, a quick video about some exceptions to the octet rule. So just like any rule that we've covered so far, there are always a couple of exceptions. The octet rule is this idea that when elements bond, they will always bond in such a way that they get a full outer shell of electrons. Normally, for most elements, that means 8 valence electrons. So that's why we call it the octet rule. There are, however, some elements that form stable compounds with less than 8 valence electrons. So they have what's called an incomplete octet because they don't quite feel like they have 8 valence electrons. We see this with some elements that are pretty unique, and those are beryllium and boron in particular. Now it also happens with aluminum, but for SL chemistry, the examples that they mainly want you to focus on are beryllium and boron. So beryllium and boron are pretty unique because they're in groups 2 and 13 respectively. They've got 2 and 3 valence electrons respectively. And most elements that are in groups 2 and 13 are what we call metals. And they're relatively low electronegativity elements because they're sort of towards the left-hand side of the table. So they've got relatively few protons for the number of energy levels that they have. So they have a pretty small attraction for electrons. But because beryllium and boron are only in the second period, so they only have 2 principal energy levels, they have relatively low shielding effect. And because of that, they have relatively high electronegativity values for being in groups 2 and 13. 1.6 and 2.0 are their electronegativity values respectively. And those aren't particularly high, but they're just kind of high for their groups. Everything else in their groups have lower values. And so what ends up happening is that electronegativity of 1.6 and 2.0 is actually high enough that they can form covalent bonds with other elements that we would call nonmetals. And so normally we don't associate metals with doing covalent bonding, but these elements do. So beryllium is a metal and boron is a metalloid, but they end up doing covalent bonding. So when they do covalent bonding, it's going to look really strange because when you try to make a Lewis structure out of beryllium, it only has 2 valence electrons to share. And so it can form a compound called beryllium dihydride where it bonds up with hydrogen. Now beryllium has 2 and hydrogen has 1. Hydrogen, we know, always forms 1 bond by forming 1 covalent bond and sharing 1 electron between each atom. So once we've done this and we've formed 1 covalent bond to each hydrogen atom, the hydrogens are satisfied. They do have a full outer shell of electrons. The beryllium has 2 bonds, which is 4 electrons. Now that's not an octet, and it always feels weird to do this. People don't like doing this, but this is actually the correct Lewis structure. It has less than an octet, so it has an incomplete octet, but it doesn't have any more valence electrons to share. So this is a molecule that forms beryllium dihydride. So beryllium can form molecules where it only forms 2 bonds, only feels like it has 4 outer electrons, and it's just an exception that you need to accept. Because it doesn't satisfy that sort of noble gas stable configuration that we look for. And boron can form 3 bonds. Boron has 3 valence electrons. So it typically bonds with things that form one bond each. So we get a bond to this fluorine, we get a bond to this fluorine. And so each fluorine on the outside is getting its stable octet, making 1 covalent bond like we would expect. And so that's not what's the exception. The exception is for the central atom, and the boron here feels like it has 6 valence electrons around itself from these 3 covalent bonds. So it does not satisfy the octet rule, but it is considered a correct Lewis structure. This is considered to be the bonding inside the compound boron trifluoride. So you need to try to remember that there are compounds that are going to break the octet rule. For SL, we only look at incomplete octets, elements with less than 8, and the 2 elements to be aware of are beryllium and boron. There could be other examples you could be asked to draw, like BeCl2 or BH3, but it's all the same. You're always going to end up with drawing beryllium with 2 single bonds and boron with 3 single bonds, and that's how they have those incomplete octets.